Hey Panthers, we are taking a look at section 5.9, which is scale, drawings, and models. So we're continuing our work in chapter 5. Remember we started off talking about ratios, and we are continuing to talk about ratios again today. But we're going to take a look at how ratios and proportions pertain to drawings and models. So we have some vocabulary terms here that I want you to be familiar with. So why don't you go ahead and pause the video now and get these filled in, and then we will continue. So our first vocabulary term here is scale drawing. Okay? A scale drawing is a proportional, two-dimensional drawing of an object. So for example, if you've ever seen a blueprint to a house, the blueprint is a scale drawing. In other words, it's not the same size as the real house. It is reduced down proportionately, and the dimensions fit onto a piece of paper. So it's a two-dimensional drawing of an object. Two-dimensional meaning that it is flat. Okay. Also, we have scale model, which is also, again, a proportional three-dimensional model of an object. An example of this, have any of you ever played with like die-cast cars? Like what are they called? Like a model car or model airplane. That's actually a three-dimensional object that you can hold in your hand. Those aren't the real sizes, right? If you have a little car, it's not the real size of a car. It is a scale model of the actual car, and the sizes are all proportional. Also, I want you to be familiar with the term scale. Scale, again, we're talking about ratios. A scale is the ratio between the two sets of measurements. For example, if you're looking at a blueprint of a house, the scale would be the actual length of your blueprint. So if you're measuring the length of the house on your blueprint compared to the actual length of the house, that would be a scale. And then we also have the term scale factor, which again is the ratio that's used to either, key terms here, enlarge or reduce similar figures. So scale factor, again, is a number or a ratio that is used to either enlarge. So if you say something is 3 times bigger, that would be an enlargement. If I say it is 1/2 times bigger, that would be a reduction. Okay. And then we have the actual ratio down here that you're going to be using, so make sure you're very familiar with this. And what we're going to be using today, the scale factor ratio, is the reproduction over the original. Okay? Reproduction over the original. In other words, the model's dimensions over the actual dimensions. Think about this for a second. If I'm talking about a blueprint of a house, would that be the model or the actual house? The blueprint would be the model. If I took the dimensions of the actual house, that would be my bottom number for my ratio. Okay, so this is a key ratio. Your model dimensions always go on top, and the actual dimensions of the real thing go on the bottom. Take a look at example 1. Example 1 wants you to identify the scale factor. Remember, the scale factor is model over actual. The scale factor, again, is the model's dimensions over the scale factor's dimensions. Okay. So here we have a two-dimensional object because we're talking about length and width. Let's start with the length. The two objects that we're looking at here are a room and a blueprint. Again, a blueprint is a scale drawing. Which of these represents the model? the room or the blueprint? The blueprint. So I'm going to label this model. And the room is the actual. These are the actual dimensions of the room. So all you have to do is take the information again. Let's focus on length. Again, model over actual. I'm going to abbreviate here. The model for the length is 18 over the actual length of the room, which is 144. Go ahead and grab your calculators and simplify. Both of these numbers are divisible by 18 actually. So this simplifies to get the ratio of 1 to 8. Okay. Let's just double check the width as well. The width, once again, we use model over actual. The model's width, grab another color here, is 13.5 over the actual width, which is 108. Once again, grab your calculators or simplify this. If I did, now again, on your calculators, when you divide 13.5 by 108, you're probably going to get a decimal. Go ahead and use your calculator to convert that to a fraction. This also ends up being 1 to 8. So again, go back. We're trying to find the scale factor. So my answer, or the scale factor, is what? 1 to 8. And that's your answer. So again, the key thing here is the ratio to find the scale factor. It's always model over actual. Model over actual. Let's take a look at a story problem. A photograph was enlarged. Photograph was enlarged and made into a poster. The poster is 20.5 inches by 36 inches. And the scale factor is 5 to 1. Find the size of the original photograph to the nearest tenth of an inch. Okay, so let's write out this information. We have two objects here, both two-dimensional. One is a photograph and one is a poster. Okay. The photo's dimensions, we don't necessarily know at the moment because they aren't given to us, but we do know the poster's dimensions. The poster's dimensions are 20.5 by 36. Okay. Now, given this information, we also know that the scale factor is 5 to 1, and again, that's given to us up here. What we can do with this information is write a proportion to find the dimensions for the photo. Okay. So, going back up here, the poster is 20.5 inches by 36. So we have a shorter side here. We have, this is the width and this is the length. Okay. When we write up our ratio, again, the widths are going to correspond with each other. So let's use, now again, think about the poster and the photograph. If I have model over actual, we took a photograph and we blew it up. What was the original piece? What's the real thing that we started with? Again, the photo. The photo is what we began with. That's the actual thing, and then we change that to get the model. So we have our model, which again would be the poster. Again, actual, we started with the photograph, so that was our actual, that was our real piece, and then we modified it to come up with our model of our poster. So the model, again, we know the model for the width was 20.5. We do not know what the width was. But we do know the scale factor, so we can write a proportion using our scale factor. So in other words, our poster, when we were finished with the enlargement, was 20.5 inches. We don't know what our original photo was, but we also know the scale factor. So the scale factor can be used to write a proportion. And remember, to solve proportions, we do what? Cross multiply. So you go ahead and cross multiply these. 5 times x is 5x, and this equals 20.5 times 1, which is 20.5. I divide both sides by 5, and we get 4 1/10. And again, taking a look at our information, this is provided to us in inches. Don't forget your units. Now that's the width. Let's do the exact same thing for the length. Again, model over actual. The actual that we started with, you know, we don't know the dimensions to that. When we were finished with our enlargement, we ended up with a poster which was 36 inches in length. So again, we can cross multiply. Oh, I forgot that. Sorry. Gotta set my scale factor up. We cross multiply here. X times 5 is 5x. 1 times 36 is 36. Divide both sides by 5, and you end up with 7 2/10. Again, what are our units? Inches. So going back to the question, find the size of the original photograph to the nearest 1/10 of an inch. And therefore, the width would be 4 1/10 inches by the length, which is 7 2/10 inches. Let's take a look at one more. Example 3, on a road map with a scale of 1.5 inches to 60 miles, I'm going to write that up here. 1.5 inches to 60 miles. The distance between Pittsburgh and Philadelphia measures 7.5 inches. What is the actual distance between the two cities? So remember, this is the key to a map. This would be the scale factor. We know that every 1.5 inches is equivalent to 60 miles on our map. So we can again use this scale to set up a proportion. Now again, 1.5 inches represents the length on the map. Okay, this is map, and this is the actual road. Okay. Now thinking about model and actual, which of these is real, a map or the actual road? The road is that, you know, the map is a reduction or a two-dimensional model of the road. So when we go up here, we know that the distance on the map is 7.5 inches. So 7.5 goes on top. What we're trying to find out is the actual distance. So once again, cross multiply. 60 times 7.5, 450. Divide both sides by 1.5. X ends up equaling 300. And again, 300 represents the actual distance. So what are my units? Miles. The actual distance. And that is it, Panthers. So again, finish this up. Please try the Try It problems. Do the best that you can. And I will see you in the morning.